Well, hello there. Goodness gracious. This is my 6th or 7th time trying to record this video. So if I seem tired or frustrated, please understand that is the reason. Not that I don't love math, because who doesn't love math? This is Mr. Dermott with the Unit 4 test review video, okay? So we're gonna start out and we are going to take a look at this first question. It's a question about the number of solutions to an equation. So let's really quickly talk about different solutions that you might get for an equation. An equation with one solution is going to be an equation where after you do all of your algebra, you end up with something like x equals 5. This is kind of what we expect when we go into equation. We think we're going to get one number where if we plug it into all the places where x occurs, it will balance the equation. One side will be equal to the other. This is kind of what we're looking for most of the time. A two-solution equation is a little bit special. It's a situation where in the second to last step of that equation, we get something like x squared equals 25. Now, I'm just going to go through the last step of solving this. Obviously, to undo squaring, we get a square root. Square root of x squared, square root of 25. Square root of x squared is x. And there's actually two square roots of 25. There are two square roots of 25. My apologies here. I'm working on this. There are actually two square roots of 25. The number that we can multiply by itself to get 25, we could do 5. But we could also do negative 5. Actually, negative 5 times negative 5 is also 25. So we show a two-solution equation with a plus or minus of that number. A no-solution situation, we go through all of our calculations, all of our algebra, and we end up with something that is kind of like a mathematical glitch. You're going to end up with just two numbers, a number on the left-hand side of the equal sign, a number on the right-hand side of the equal sign. So you might get 5 equals 6. 5 equals 6, that's not true. That's why I call it a glitch, right? This doesn't make any sense. When you get that nonsensical answer, a number that equals a number that it's not itself is your final solution there, that is a no solution situation. And then we have our infinite solution situations. And this is where you go through all of your calculations, all of your algebra, simplify it as much as you can. Your variables cancel out just like in a no solution, but you end up with a number like 5 equaling itself, which is actually a true statement. Goofy, but true. So in this situation, we would call that an infinite solution, okay? So let's go ahead and start working through this. If you're working on this in the classroom for credit, you need to show all the work that I show, right? Everything that I write. And if you're using this to study at home, please feel liberated, encouraged to pause, rewatch, rewind, fast forward if you know the question, but really use this as your opportunity to take a deep dive into this review. I'm going to copy this back down, so copy it with me. Negative 3 times x plus 1 plus 3 equals 3 over 2 times negative 2x plus 2 minus 2. Oh my goodness, so many terms. And so here, our first step is going to be to deal with these parenthetical expressions. We deal with those by distributing the term directly before it. So we're going to distribute this negative 3. Negative 3 times x, negative 3 times 1. Negative 3 times x is going to be, and actually before I do that, let me keep my work nice and neat. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. And then remember, if I have a term like this one right here that I just haven't touched, I'm just going to drop it on down just as it currently is. Positive 3 equals, then I need to distribute this guy right here. So when we're distributing a fraction like this, all I have to do is, I'm going to do the work on the side, and you don't need to do this work on the side. We're going right across the top, right? And that's going to give me negative 6x. And then we could go through the trouble of putting that implied one denominator and multiplying straight across. But all it's going to do is duplicate that denominator right there. And so I'll let you guys skip that step. Just focus on multiplying numerator by numerator and then repeating that denominator underneath, right? So our first term is going to be negative 6x over 2. Our second term, 3 over 2 times 2, is going to give me positive 6 over 2. And then we're going to go ahead and drop down this guy just as it is because we haven't touched it. That's a minus 2. Let's go through and make things a little bit simpler, okay? So one thing that I'm going to point out is that this guy right here, 6 divided by 2, that's quite easy. You know that 6 divided by 2, positive 6 divided by 2 is going to be positive 3. Likewise, you know that negative 6x divided by 2 is going to be negative 3x. That makes it a little bit easier. It gets rid of some of our fractions and gives us a clearer mind as we move forward. Our next step is going to be to find our like terms and combine those like terms, right? So circling these like terms, I'm going to go ahead and combine these guys for the next step. Negative 3 added to positive 3, that's going to cancel out. It's going to be 0. I'm not even going to write that. I'm just going to drop down my negative 3x, right? Again, that guy came from right there because I didn't touch him in that step. And then positive 3, and I'm going to subtract 2 from it, is going to leave me with a positive 1. And again, here I'm going to take this negative 3x, I'm going to drop it down just as it is, get negative 3x. And then my next step would be to get I have a variable on either side of the equal sign, so I want variables to the left. So I'm going to take this guy, I'm going to cancel out with a positive 3x. What I do to one side, I'm going to do to the other. When I do that, look what happens here. These cancel to 0. These likewise cancel to 0. So over here, the only thing that I have left is my 1 is going to drop down because I haven't touched it in that step. And I've got nothing to put over here. And so in math, when we have nothing, there's a easy peasy number for that. It's just a big fat 0. And so we're left with this little bit of funkiness of 0 equals 1. Well, y'all, 0 doesn't equal 1. That's that mathematical glitch that I was talking about. That's going to be a no solution for number 1. Moving on to number 2, we did some work with word problems in class. And y'all, it's all about reading the whole problem, isolating that variable, and kind of working around that variable. So when 12 is added to the number that is produced by tripling the number x, the result is 12 times that number that is 5 less than x. What's the value of x? So starting here, man, that is a lot of words. It can be daunting, but let's see. We can start with, all right, we've got the number x, right? So that's our variable. So we're going to start out with that x. And it's, tripling x. Well, that's easy. That's a 3x. Got that. And then I'm going to kind of build out from there. 12 is added to the number that is produced by tripling the number x. So that's going to be 3x plus 12. And then over here, I see the result is equal to, well, y'all, that's your big fat equal sign right there. See here, 12 times the number that is 5 less than x. All right, so we've got x here. 5 less than x. All right, so let's see. That's x minus 5. And then we're looking for the result is a number that is 12 times the number that is that is x minus 5. So it's going to be that whole thing times 12. So now we've got an equation with numbers, and we can work with that. This isn't going to be a terrible equation to work with. So let's start. We got this to distribute, right? We got our 12 to distribute, so we're going to distribute it to both of those terms. And that's going to give us 12x minus 60. And then we're going to drop down everything else, 3x plus 12. We need to get our variable on the left, right? So there's our variable. That's a positive 12x. I'm going to get it off of this side by subtracting. And I'm going to subtract 12x over here. When I do that, these guys are going to cancel right here. I'm going to bring down my negative 60 just as it is. And then over here, 3 minus 12x, that is going to be negative 9x. If you're one of the people that when you look at that, you want to say 15 or negative 15, then you're a person who would benefit from using a number line to figure that out. Ain't no shame in it. I want to get my variable term here on its own, so I'm going to have to deal with this guy right here, this positive 12. We deal with that by canceling it with a negative 12. And then that is going to leave us with negative 72. Negative 9x equals negative 72. So our last step is we want to get x all on its own. This coefficient of negative 9 is messing that up. This is a multiplication happening between negative 9 and x. So I'm going to use a division to cancel it. What I do to one side, I'm going to do to the other. It's easy. These cancel out, right? That's going to leave me with x. I knew I was going to get there. And then negative 72 divided by negative 9. If you know your 9's times tables, you know that the number you're going to get is 8. But what about the sign? It's a negative divided by a negative. Y'all know that's a positive. So x equals positive 8. See that as answer choice A. Okay, we're rolling. So the next question is we have to select two equations that have infinitely many solutions. Go back up here. Remember that our situation where we have infinitely many solutions is where our variables cancel out and we get a number times itself. So I'm just going to have to go through here. Man, I'm going to have to work these. I hate it. Some labor. 2 times 7 and 2 times, it's a negative 4x. 2 times negative 4x. And then we're going to have to distribute this guy here. 4 times 5 and then 4 times negative 2x. Should be a negative 6 right there. 2 times 7 is 14. 2 times negative 4x is negative 8x equals. 4 times 5 is 20. 4 times negative 2x is negative 8x. And we've got this negative 6 hanging out here. We're going to bring it on down. Last step is we're going to find our like terms and we're going to combine those things. We don't have any like terms on this side. We have these two. I'm going to bring all this right over here. So I've got 14 minus 8x equals, see here, 20 minus 6, 14 minus 8x. So I can tell you right now, this side is identical to this side. That is the situation where you're going to have infinitely many solutions. I'm going to go ahead and work the thing out to its end. I'm going to get my variable over to the left. So I'm going to add 8x, add 8x. These guys cancel. And then I'm left with 14 equals 14. And that is an infinitely many solution situation. So A is one of our two infinitely many solutions. Let's roll on to B. 6 times x, that's a negative 9. 6 times negative 9, that's going to be 6x minus 54 equals. And then here, really all we have to do is combine some like terms. We've got 6x and positive x. They're going to combine to leave us with 7x minus 54. And I can tell you right now that this is going to be a one solution equation because these x's are not going to cancel out. You know they're going to cancel out if your x's on this side are the same as the x's on this side. These x's are not the same. So if I go through my process here, I'm going to come out with, what do I do? Subtract 7x, and then I would end up with negative 1x minus 54 equals negative 54. And then I'm going to add 54, cancel, and I end up with negative 1x equals 0, and then that's to end up as x equals 0. So this is a one solution equation, so this is not an answer. This one I'm going to distribute that 4. I'm going to get 4 times x is going to be 4x. 4 times positive 4 is 16 equals, 4x plus 16 equals. 2 times 2x is 4x. 2 times positive 5, that's a positive 5, is 10. And then we've got a positive 6. My next step would be just to combine like terms. And that's going to give me, on this side, I'm going to end up with 4x plus 16 equals 4x plus 16. Remember, just like up here, when you get down to this side being exactly the same as this side, you have an infinite solution situation. So my preliminary hunch is that my answer is A and C. I'm going to go ahead and work out number 8 just for good measure, or work out option D just for good measure. 5 times x is 5x. 5 times negative 8 is negative 40. Bring down my 10 equals 5 times x is 5x. 5 times positive 2 is 10. Need to get, let me go ahead and get my x's over here on the left. So I'm going to say minus 5x, minus 5x. Oh, there they go. So they canceled. And then I'm going to go ahead and while I'm at it, I'm just going to go combine these two like terms. That's going to give me negative 30 equals 10. And y'all, we know that negative 30 does not equal 10, so that is no solution. So that was not our answer. We're going to roll on to the back of the first page. Okay, so this question is asking which value satisfies the equation below. And all that means is satisfies the equation. That's a fancy way of saying, hey, solve for x. Okay, so we're going to have to solve this guy for x. Let's go ahead and start by copying our equation down. Give ourselves lots of room. Negative 1 over 2 times negative 10x plus 4 plus 6 equals negative 10 minus 9 times negative 7x. Ooh, I'm running out of room. Minus 1. First step is going to be to distribute, right? So distributing this negative 1/2, again, I'm just going to lead with my numerator. And one little trick I want to point out is whenever I have a negative sign or a variable, I like to actually attach that guy just to the numerator. I find that really helps me get some clarity in this process. You'll see why in a second. So as I'm distributing that thing through, I'm going to say negative 1 times negative 10x is going to be positive 10x. And then remember, just like I showed you in question number 1, when you have a whole number multiplied by a fraction, you can just drop that denominator right in under the fraction. I'm going to point out too that I think I can go ahead and simplify that a little bit, right? 10x divided by 2, that could easily just be simplified to 5x, right? And then negative 1/2 times 4 is numerator to numerator. Negative 1 times 4 is going to give me negative 4 Drop my denominator under. And again, -4 divided by 2 is pretty easy. That's going to give me -2. I'm going to drop down everything else. I've got my +6. Go ahead and draw my line. And then let's go ahead and distribute this thing. There's -9 to -7x, and then -9 to -1. So -9 to -7x, 9 times 7, 63. Negative times a negative is a positive. So that's going to be 63, positive 63x. -9 times -1, negative times a negative is a positive. That's going to be +9. Then we've got -10. All right, so there we go. And again, we just drop that 10 straight down there. Next step is going to be to make things a little easier. Let's combine some like terms real quick. We got some like terms on both sides that we can combine. So -2 combined with add 6 to it is going to give me +4. I'm going to bring down my 5x just because I haven't touched it. And then -10 plus 9 is going to leave me with a -1. And then I'm going to bring down my 63x, +63x. Okay, so next step, let's work and get our variable on the left. So got my variable over here, this +63x. I'm going to subtract 63x, subtract 63x. Man, this would be a silly place to make a mistake. Again, a number line, if you're not confident in these types of calculations, it's going to give me -58x plus 4 equals -1. I'm going to deal with this guy so I can get my variable term on its own. That's -4, -4. Do that calculation. These guys cancel. This is going to leave me with -5. Then my -58x is going to come down right here, just as it is because I haven't touched it. Last step is going to be getting rid of this right here, getting rid of this -58 coefficient. This is being multiplied by x, so I'm going to reverse it with a division. Reverse it with a division. Over here, that's easy. We know that those guys just cancel. It's going to leave us with an x. And then a negative divided by a negative ends up being a positive. We actually can't simplify that. That's going to be 5 divided by 58. Man, it's an ugly, ugly fraction, but I'm comforted because I see that that fraction is right up here among my answer choices as answer choice A. Okay. Moving on, we got just straight up solving an equation. I'll tell you, the only thing that's a little hairy about this is we got this funky little fraction right here. So if you're like many and you need a little review on fraction work, this is a great place to look. So let's go ahead and solve this equation. I'm going to give myself a little bit of room. I'm going to solve it right over here. So I'm going to copy it down. 3x plus 4 over 5 equals 7 minus 2x. So the fraction's going to make this tough, but I think we can do this. This is one that you're going to want to watch again if you are averse to fractions like myself. So there's really nothing for me to combine here. My first step is going to be able to get my variable on the left, right? So I'm going to add 2x, add 2x. Oh man, they're making it quite easy for us here. 5 looks like an easy number to work with. So we've got here, we've got 5. Said they were making it quite easy. I thought they were leaving us with 1x, but not the case. Plus 4 over 5 equals 7. And man, it's all in the fraction. So let's go ahead and just say we're going to subtract 4 over 5 and subtract 4 over 5. Well, this one's easy, right? Those just cancel out. This one, for a lot of us, is going to be a little bit tough. So let's kind of talk about how to do that. Like, I'm going to just kind of show you this work over here, all right? So when we get 7 minus 4 over 5, when we're adding or subtracting fractions, we need to get the numerator to match up. So right now, the numerator for the whole number 7 is 1. We can get that numerator up to 5, right? We can get that numerator up to 5 by multiplying both the numerator and denominator here times 5. I'll do that in red because that's kind of my thought process. 5 times 5 times. We recognize that 5 over 5 is just 1. We're allowed to multiply something by 1. So leaving with 35 over 5 minus 4 over 5, okay? When we're subtracting fractions or adding fractions, we're only dealing with our numerators. So 35 minus 4 is 31, and you just keep the denominator, right? You keep the denominator as it is. That's 31 over 5. So we did this work, and we can go and show that in our math here. So we've got 5x equals 31 over 5. That is a hairy, ugly fraction. I'm not going to lie. So now, algebraically, we know that we have a multiplication going on here. So we've got to use a division to reverse it, right? Woo, I just hate dividing a fraction by a fraction, right? So 31 divided by 5 divided by 5. So again, guys, I want to kind of take this and I want to kind of think through this process right over here. So I'm not a big fan of using this division symbol. Not a big fan at all of that division symbol. But when you're dealing with fractions, that division symbol is helpful. So I'm going to set it up like this, right? We're starting with 31 over 5 divided by 5. So first of all, we need to make it a fraction to fraction situation. That's 5 over 1. And y'all, I don't know if you remember 6th and 7th grade, but the trick here is going to be the old keep, change, flip. Keep, change, flip. We keep this fraction as it is. We change this to a multiplication sign. And then we flip. We get the reciprocal of that fraction. So when we do that, we end up with 31 over 5 times, that's our change. So we kept that, we changed that. And then we're going to flip this, and we get 1 over 5. And man, multiplying fractions is easy peasy, right? Just go straight across. So 31 times 1 is 31. 5 times 5 is 25. We get 31 over 25. So x equals 31 over 25. And thank heavens. There's that answer right there. Y'all, this is something that, this is one of those situations where rewatching and working on a couple of these on your own would be really helpful. If this is something that you didn't have a strong basis in from 6th and 7th grade. Okay. Well, this we can deal with. This next question is easy in comparison to the last two, which had some pretty hairy fractions and hairy numbers. So let's take a look at this one. Real straightforward. Again, we have our first process. Our first step is going to be that multiplication, distributing that number outside of the parentheses. And I apologize. I do need to rewrite this. So I'm going to say 3 times x plus 8 minus 4x equals 10x plus 4. So my first step is to distribute this 3. 3 to x, 3 to 8. 3 times x is 3x. 3 times 8 is positive 24. Then I've got my minus 4x equals 10x plus 4, okay? My next step, I'm gonna go ahead and just combine these like terms really quick before I do anything else. 3, and I'm gonna add a negative 4, 3 minus 4. It's gonna give me negative 1x plus 24 equals 10x plus 4. Got to get my variable on the left, all right? So I'm going to deal with this guy right here. Subtract 10x, subtract 10x. Oh my goodness, and I see what I did right here. Y'all, I deeply apologize. I just realized this, because I realized I was about to get a pretty funky number here. I monkeyed around this. This was supposed to be 2. I apologize. My apologies. It's going to change a lot. So 2 times 8 is 16. I apologize, guys. So let me just redo that step. It's going to be 2x. 2x, negative 4x is going to leave me with negative 2x. Oh, I'm so sorry. Now when I take away 10x from that, that's going to leave me with negative 12x. Oh my goodness, I'm sorry. I don't know how that became a negative. I make one mistake and it's one thing follows after another. Okay, my apologies. I'm gonna start this guy over really quick. I was messy and I started getting craziness there. Craziness. Okay, so let me try this again over here, and I'm actually gonna get out a new sheet just so that okay. So here we go. Let's try this again. Let me copy it down correctly this time. 2 times x plus 8 minus 4x equals 10x plus 4. I'm going to zoom a little bit, all right? So I'm going to do my distributing. 2x plus 16 minus 4x equals 10x plus 4. I'm going to go ahead and combine my like terms here and here. That's going to leave me with negative 2x plus 16 equals 10x plus 4. I need to get my variable on the left, so I'm going to deal with this. Negative 10x, negative 10x. That's going to leave me canceling here, and that's going to leave me with negative 12x plus 16 equals 4. And then minus 16, minus 16. These cancel, obviously. 4 minus 16 is, what is that? Negative 12? Negative 12x equals negative 12. One step away. I got a multiplication going on between this guy and x, so I'm going to divide by that guy. Negative 12, negative 12. And that is going to leave me with x equals, remember, any number divided by itself is plain old 1. So our answer there is going to be 1. I apologize too if I did some of that work where you could not see it. Take a second, make sure that you kind of see that process there. Pause it if you need to. This was a pretty straightforward problem. I think overall really doable for us. Very easy for anyone that's been in regular attendance. Okay. Consider the equation below. Which statement is true? Well, unfortunately, this is another one where you're gonna have to solve the equation to make it happen. So let's go ahead and do step number 1 by copying that equation with neatness and fidelity. 3n, that's a plus sign, friends, plus 2 times n minus 2 equals 4n minus 1. I'm gonna go ahead and distribute this positive 2 to each of those terms right there. That's gonna be 2 times n is plus 2n. Positive 2 times negative 2 is gonna be negative 4. I'm gonna bring on down my 3n just as it is. All of that equals 4n minus 1. Next step is gonna be combine these here like terms. 3 and 2, 3n and 2n come together to make 5n. We've got minus 4 equals 4n minus 1. I'm gonna continue to solve. So minus 4n minus 4n. It's gonna leave me, and I'll tell you, I mean, even at this point, I could actually stop at this point because the way this question's set up, it doesn't even need a solution. I can see that I'm not gonna cancel out my variables. I know this is gonna be a 1 solution. It's not a 2 solution because nothing is being squared. It's gonna be a 1 solution. I'm gonna go ahead and circle that now, but let's go ahead and see this through to the end. Why not? So it's gonna be 1n minus 4 equals negative 1. So we're gonna add 4 to cancel that out. And these cancel, and I would get n equals 3. And that's our only solution to that equation. Okay, rolling through. Got another one to solve. Straight up equation. This should be very much in everyone's comfort zone at this point. Start out by copying it with neatness and fidelity. Negative 69 equals negative 5 times x plus 2 minus 8 times 5 minus 3x. And go ahead and start. We've got a couple things to distribute. We haven't had many where we've had to distribute 2 sets on the same side, but that ain't no thing. We're just gonna multiply right there. Do the same thing with this negative 8 over here. So we're gonna get negative 5x, that's my first. Negative 5 times positive 2 is gonna be negative 10. And then let's do this one. Negative 8 times 5 is negative 40. Negative 8 times negative 3 is going to be, I know 8 times 3 is 24, 24x. It's going to be negative times negative, a positive. Positive 24x. All right, so I want to point out one thing I'm seeing here is that my variables are all on the right. And so if your variables are already all on one side, you're welcome to just leave them there and flip them as a last step. Let's go ahead and look at our like terms. So circle our first term. Do we have anything we can buddy it up with? Oh yeah, positive 24x. I'm gonna double underline our second term, negative 10. Oh, that can go with negative 40. Let's combine these guys. So negative 5x and positive 24, so this is really 24x minus 5x. Oh, that's negative 9, that's positive 19x. Negative 10 minus 40, again, negative, and we're going 40 more negative, that's gonna be negative 50. Oh man, I see I'm gonna come to a nice neat number eventually. I'm not sure how. Need to get my variable on its own. Let me get rid of this guy right here. Cancel out a negative 50 with a positive 50. And a positive 50. Ooh, I think I see which answer it's gonna be. All right, and that is gonna be negative 19 equals 19. X. Okay, so what we're gonna do here, we gotta get rid of this coefficient. It's a multiplication, so we're going to cancel it with a division, cancel it with a division. These guys cancel. A number divided by itself is 1, but look, we've got a negative divided by a positive, so that's going to be a -1 equals x. If you're like me and you can be a little particular, then feel free to just switch those around and say x equals -1. The answer is right up here, it would be B. All right, rolling on. Let's go ahead and rewrite it with neatness and fidelity. 4x plus 3 minus 6x equals 1 minus x. This is easy in comparison to the ones we've been doing. So step 1 is going to be, let's combine these here like terms. All right, these two are going to come together. 4x minus 6x is going to be minus 2x. Drop down my -3. Drop down everything else over here. All right, variables on both sides. I want my variables on the left. Minus x, so we're going to cancel it out with a positive x. Cancel out with a positive x. Those cross out. Be left with just plain old 1 over here. And I've got -2x plus x. That's going to leave me at -1x plus 3. And then I need to get my variable term here on its own. I'm going to deal with this guy that way. I'm going to get a +3. Let's cancel it out with a -3, -3. These cancel, that's easy. That's going to leave me with a -2 equals -1x. Okay, we can't just leave it as a -x. We're looking for the value of positive x. So the way that we deal with it is just the way we would deal with any coefficient we don't want. That's a multiplication, so I'm going to do a division by -1. Divide by -1. These cancel. A -2 divided by a -1 is going to be a +2. X equals 2. Answer choice is C. All right, we're getting there. We're getting there. It's a long test, I know. All right. T, all right, let's see here. Start out, we've got just another solve for T. Doesn't matter whether it's T, X, M, whatever your letter is, whatever your variable. Let's go ahead and start by copying it down with neatness and fidelity. I'm going to make it a capital T just because that tends to look like an addition sign. T minus 3 times 4 minus T equals -24. Ooh, this is a straightforward question. Start by distributing that guy right there, right? -3 times 4 is -12. -3 times -t is going to be +3t. Remember, negative times a negative is a positive. All right, equals -24. Let's look for some like terms. Those guys are like terms. You can combine them. So t and 3t, it gives me 4t minus 12 equals -24. We've got this -12. We need to get that off of that side. We're going to add 12. We're going to add 12. These obviously cancel, and that's going to leave me with -12. 4t equals -12. We're just one step away. We're going to divide by this leading coefficient of 4, +4. These cancel. I'm left with t. And then -12 divided by +4. Negative by a positive is a negative. T equals -3. Answer choice B. All right, triangles. We got a little geometry spice in here. So let's take a look at this. So remember that the interior angles of a triangle are going to always add up to that big magic number of 180. So we're going to have to write our own equation. This is really easy algebra. The hard thing is to remember how to set it up. It's not even that hard. We know that all of these angles, when I add them together, are going to equal 180. So what equals 180? Well, 20 degrees plus 90 degrees. Remember that little square is our sign for 90. Plus x plus 75. I'm going to write it just as it is. All right. Exercise in combining some like terms. Let's see what we get here. These guys come together to make 110. Add that to 75. That's going to give me what? 185. So we've got x plus 185 equals 180. All right. You need to get x on its own, so we're going to deal with that positive 185. Let's go with negative 185. Negative 185. Those are going to cancel. Got x equals negative 5. That is my final answer right there. Okay, another little geometry problem. Guys, remember that when we have parallel lines that are crossed by a transversal line, there's only two angle relationships. We either have angles that are congruent or we're going to have angles that are supplementary, right? This angle is supplementary to that one, but it's also supplementary to that one. I can tell with my eyeballs. These are called alternate interior angles, but y'all, my eyeballs tell me these are the same. These angles are congruent, knowing that there were only two options. Let's go ahead and think about how we can set that up in an equation with an equal sign. Well, earlier, if you remember, we said that all of these angles added together equal 180. We're not adding these angles together. They're equal to each other. So we've got 31x minus 2 equals 29x plus 2. Pretty straightforward here. We're going to go ahead and get our variables on the left because we have variables on both sides. All right. These are going to go back to my blue. Sorry. These are going to cancel out. This is going to leave me with 2x minus 2 equals 2. All right. So let's deal with this extra term. We want this constant term off of that side. So it's going to be plus 2 plus 2. That's easy. Those two are going to cancel. These two are going to add together to be 4. 2x equals 4. You need to work backwards. Divide by 2 to undo that multiplication. We're going to get x equals 4 divided by 2 is 2. X equals 2. Solving for x. Okay, so just kind of pencil in my positives and negatives because it is a little bit of a light copy. My apologies. This is not terrible. Let's start out by just copying down my problem with neatness and fidelity. So we've got 1 minus, open those parentheses. Again, a trick that I like is whenever I have that x that is the variable attached to a fraction, I like to put it in the numerator, right? 1x over 2 plus 2 equals negative 2 plus 2 times negative, and I really like to do the same thing with the negative signs, guys. When I get that negative sign, I like to put it into the numerator just to simplify things for me. Negative 1 over 2, negative 1x over 2, minus 1. All right. First step is going to be to distribute. Now, when we have this, just this negative sign, remember that we are distributing a negative 1. 1 is the implied coefficient there, the implied term outside of that. So we're going to multiply, sorry, same color. We're going to multiply this negative 1 times the first term times the second term. Let's go ahead and do that. Negative 1 times 1x over 2 is going to be negative 1x over 2. Negative 1 times positive 2 is going to be negative 2. And then over here, likewise, 2 times negative 1x is going to be negative 2x over 2. Ooh, I can simplify that. I'll do it in a second. 2 times negative 1 is going to be negative 2. And then I need to, of course, go ahead and make sure that I bring my remaining terms down. Don't forget that little 1 out there. So that's 1 minus 1x over 2. And then we've got this negative 2 over here that we're going to bring down. Negative 2 minus 2x over 2. All right, let's see what we can do here. So my first step is going to be to combine like terms, all right? So I got this 1 and this negative 2 over here. I've got this negative 2 and this negative 2. Let's go ahead and combine these, make things a little bit easier. So I've got negative 1x over 2. 1 minus 2 is minus 1 equals 2, and negative 2 minus 2 is going to give me negative 4. And then I've got minus 2x over 2. All right. So here, my next step is going to be to get my variable term over on the other side. And you know, y'all, I'm kind of glad I didn't simplify up here, because as I look at it, look at that. My denominators are the same. This is going to be easy for me to combine, right? To combine it with the other one. So let's do plus 2x over 2 plus 2x over 2. And these guys are going to cancel. Negative 1x, and I'll just do this out to the side here. Negative 1x over 2 plus 2x over 2. Remember that when we have a fractions, adding fractions, you know, when the denominators are the same, then we can just add the numerators, right? So negative 1x plus 2x, that would leave us with 1x over 2 minus 1 equals negative 4. Need to get this variable term right here on its own, so I'm going to deal with this guy right here. So let's add 1, add 1. These cancel. This is going to leave me with negative 3. And then I've got 1x over 2 equals negative 3. Want to get rid of this right here. So there's a division going on here. So I'm going to multiply that whole side by 2, multiply that whole side by 2. That's going to leave me, cancel, cancel. That's going to leave me with 1x, or just plain x, equals negative 6. And again, there's that answer choice right there. Okay, so this one is probably going to be, I'll be honest, this is the most difficult one probably on the test. So let's just kind of talk about how we're going to solve this. So step number 1 is to rewrite it with neatness and fidelity. X plus 5 over 2x minus 6 equals 5 over 2. I highly recommend you watch this a couple times, all right? Rewinding this, watching this a couple times. These are all locked up. I can't do anything with these until I get this guy off of the denominator. And when I've got something on the denominator, you know how I get rid of it, right? We did it right up here. Look, when I had this 2 on the denominator that I wanted this gone, I multiplied by that denominator. Well, it's no different here. we're gonna make our first step multiplying by our denominator, which is 2x minus 6. That seems like a lot to multiply by, I know. We're gonna do it over here. 2x minus 6. But y'all, I promise it is not that bad. Look, here, this is easy peasy on the left-hand side, right? That crosses out that, and I'm just left with x plus 5, right? Over here, you know, it really is not as bad as it looks. Anytime that we're multiplying something by a fraction, we multiply by the numerator, and then we bring the denominator over. Y'all, it's not bad. Look, think about this. All you're doing is this right here, this multiplication, is the same as this multiplication. Y'all have done this a bunch of times, right? 5 times 2x, 5 times negative 6, right? That's going to give us 10x, positive 10x, yeah, positive 10x minus 30. And then remember, anytime we're doing that, we're going to bring down our denominator, just as is, over 2. So, got a couple options here. The way that I would probably deal with this is to multiply this whole side by 2, multiply this whole side by 2, distribute that 2, you're going to have 2x, let me get on down here, 2x plus 10, these guys are going to cancel, you get 10x minus 30, need to get my variables on the left, so I'm going to subtract 10x, subtract 10x, and it's going to give me negative 8x plus 10 equals negative 30. And then we need to get rid of this term here, this positive 10. So we're going minus 10, minus 10. These are going to cancel. This is going to leave me with negative 40. And then we're going to get negative 8x equals negative 40. And then what do we do to get rid of this coefficient here? We just divide by negative 8. Divide by negative 8. Cancel. Cancel, we're left with x equals 40 divided by 8 is 5. A negative divided by a negative is a positive. So the answer is going to be a positive 5. There we go for our answer right there. Fabulous. Almost there, almost there. I'm going to solve this guy right down here. This is not many lines of solution. All right, so I'm going to start out by copying neatly. Negative 10 plus 2n squared equals negative 2. I need to get my variable term on its own, so I'm going to add 10. I'm going to add 10. These guys are going to cancel. That's going to leave me with 8. I've got 2n squared equals 8. 2n squared, I'm going to divide by 2. Remember, whenever I have this exponent, I'm going to deal with my exponent last. Very important we deal with the exponent last most of the time. Divide by 2, divide by 2. I get, I'm going to do this right over here. I'm going to get n squared equals 4. Oh, good. I see a perfect square here. And then I've got to undo this square. All right, we're going to undo that square with the square root. Square root of n squared is n. And the square root of 4, there's two values that can multiply by itself to get 4. It would be positive or negative 2. There's our answer for A. Okay, we saw a couple problems like this in class as we were working on word problems. Now, they didn't have to do with triangles, but they did have to do with consecutive integers. Consecutive integers. Remember, the way that we think about consecutive integers, if I start with the first number and I'm looking for the next two numbers that immediately follow it, it's x. And that second number is x plus 1. And that third number is x plus 2, right? So like if I start with 1, 1 plus 1 is 2, 1 plus 2 is 3. Sometimes you might get a question that asks for even consecutive integers. And that's kind of the same thing, right? Evens count by twos. X is the first number. X plus 2 is your second number. X plus 4, oh, messy. X plus 4 is your third number, right? So if we started with 2, our second number would be 4. Our last number would be 6. So let's apply it to this question. Lengths of 3 sides of a triangle are consecutive integers. If the perimeter is 90 feet, find the value of the longest of the 3 sides. All right, guys, so we've got this triangle right here, and you're going all the way around, it's going to be 90. So really, this plus this plus this is going to equal 90 feet, right? And they're only 1 unit apart. Common sense tells me that those 3 values are going to be somewhere around 30, right? Because there's 3 sides, they're almost equal, probably, I don't know, somewhere around there. And as I'm thinking about it, you might be able to work it out in your head, but we're going to work it out algebraically, right? So we've got this equals 90. Okay, so what is the equals 90? Well, we start with our first side. Our shortest side is x. And again, when we're talking about consecutive numbers, that's our first term. That's our first side. Our second side we're going to add is going to be that value plus 1 foot. And then our third side is going to be that value plus 2 feet. So once we kind of get it figured out here, it's really not a bad problem to work out algebraically. So we have our 3x values, x plus x plus x, that's easy, that's 3x. And then we have our other like terms, 1 and 2. Those two come together to give me 3. And those are going to equal to 90, all right? Easy algebra here. So I need to get this guy on its own, so I'm going to deal with it by taking this away from both sides. These guys right here are going to cancel out. That's going to give me 87. 3x equals 87. Going to divide by 3 to undo that. Now, I can't say that I've often had occasion to divide 87 by 3, but I know 87 is pretty close to 90, and I think that's going to be 29. X equals 29. Now, here's the trick. This is why this is a tricky question. Go back to this triangle up top. Which side is 29? Well, it's the x side, the shortest side. So that side is 29. That side is 1 more than 29. It's a consecutive integer. And then that last side is 31. Don't forget, it's looking for the longest. Ooh, this is a tricky question. It's looking for the longest of the 3 sides. The longest of those 3 sides, y'all, is 31. Ooh, that is a diabolical question. Last question. Second to last question, sorry. I'm going to copy it down with neatness and fidelity. -7, 2x plus 8 equals 3 times -3x minus 2. I'm going to go ahead and distribute. That's going to leave me -7 times 2x is -14x. -7 times 8. 7 times 8 is 56. 56. Negative times a positive is a negative 56. Equals. I'm going to distribute on this side right here. 3 times -3 is -9x. 3 times -2 is -6x. Oh, sorry, just -6. There's no x attached. Forget about that. All right, so I've got a variable on both sides. I want my variable on the left. So I'm gonna add 9x to this side, add 9x to this side. These guys cancel out. And that's gonna be, negative 5x minus 56 equals negative 6. Okay, want to get my variable term on its own. This guy right here is messing us up, so I'm gonna negative 56 cancel it out with a positive 56, positive 56. And that's gonna leave me 50. That's gonna be negative 5x equals 50. Divide by negative 5. Divide by negative 5. These are going to cancel. That's going to leave me with x equals 50 divided by 5 is easy. That's going to be 10, but remember, positive divided by a negative, that's going to be negative 10. And you're going to have to enter that answer manually, but that is your answer for that question right there. And the last question. The last question. So we've got, and I'm not even going to rewrite this because I have plenty of room to work it. My first step is going to be to get my variable term on its own. This guy right here is messing me up, so I'm going to add 75 to that side, add 75 to that side. These guys are going to cancel out and bring down my x cubed, x to the third power. Remember, that's x times x times x. Equals 125. And if you remember your cube roots, 125 is one you should know, I think. What number can I multiply it by itself 3 times to get 125? By the way, it's a cube root, so that's how we write a cube root, if you remember. This is going to leave me with x equals, let's think. Well, you should just know at this point, but 5 is the number that you can multiply by itself 3 times, right? 5 times 5 is 25. Times 5 one more time is 125. So that is my answer. All right. Again, the questions that are going to be real bears that I think are worth you really reviewing are going to be this guy right here. I would definitely look this question over again because it's something that's a little bit out of the box for us. And then the other one that I would definitely want to look over again, I feel like the beginning of this was a little bit of a challenge. I felt like the fractions were a little bit challenging in this one. Little fraction work that you might want to work on. Again, this one, little fraction work that you might want to just review. But I wish you all luck on the test. Please make sure again that you show all your work just as I did here. And thank you for your time.